Effect of centrifugal and coriolis force due to earth rotation. Effect of centrifugal force and coriolis force due to earth rotation. Effect of centrifugal force and coriolis force due to earth rotation. Since the earth is rotating uniformly about its own axis from west to east, a reference frame fixed on its surface is clearly a rotating frame of reference. As a result, two frictious forces, the centrifugal force and the coriolis force, must act on a particle at rest and its motion respectively. Relative to rotation frame of reference, let us examine the effect of these two forces. First is effect of centrifugal force. Effect of centrifugal force. Effect of centrifugal force. Effect of centrifugal force. The centrifugal force on G. Effect of centrifugal force on G. The acceleration of a particle in a uniformly rotating frame is given by the acceleration of a particle in a uniformly rotating frame is given by vector A equal to vector A dash plus 2 omega vector cross V dash vector plus omega vector cross in bracket omega cross R vector. When a particle is at rest in the rotating frame, the coriolis force acceleration. When particle is at rest, this is the equation number 1, is at rest and the rotating frame, the coriolis force acceleration, coriolis force acceleration 2 omega vector cross vector V dash equal to 0. In such a case, the body is under the action of the centrifugal force. In such a case, the body is under the action of centrifugal force. The body is under a centrifugal force. Centrifugal force. The body is under the action of the centrifugal force only given by omega vector cross omega vector R vector. Therefore, acceleration of the particle with respect to the inertial frame will be therefore acceleration. Therefore acceleration of the particle acceleration of the particle with respect to inertial frame will be with respect to inertial frame will be vector A equal to vector A dash plus omega vector cross vector R. Vector A dash equal to vector A minus omega vector cross vector R. The earth is rotating from west to east. The earth is rotating from earth rotates west to east. And reference frame fixed in it is rotating frame of reference. To consider the effect of centrifugal force on the acceleration due to gravity, we take angular velocity vector omega along the y-axis and the x-axis is taken perpendicular. 1 minute. This is the earth and this is the origin point, and this is the x-axis, and this is the y-axis, and this is the earth rotation direction, and the y-axis, and earth rotates its own axis, then this is the C point, and this is the P point, and R omega square. This is the angle lambda. And to consider the effect of centrifugal force on acceleration due to the gravity, we take angularly velocity vector omega. Along the y-axis. And x-axis is taken perpendicular. To it is as shown. Then the actual value of G. At a point P. In the latitude, lambda will act along the direction PU. Lambda will act along the direction PU, where O is the center of the earth. The component of G is the components of GR. Components of GR minus G cos lambda I along x-axis and minus G sin lambda J along y-axis. Also omega vector equal to omega j. From P draw PC, from P draw PC, perpendicular to OI, then CP equal to R, then CP equal to vector R, where R is the radius of the circle, in which a particular item P rotates, because Earth rotates its own axis. So hence CP equal to vector R cos lambda equal to R cos lambda I, where R magnitude of the radius of the earth, where R magnitude, of the radius of the earth, of the radius of the earth. R is the radius of the earth, OP, R is the OP. The observed value of acceleration due to gravity at point P, taking into consideration the effect of centrifugal acceleration and neglecting the effect of coriolis acceleration due to the rotation of Earth is given. Vector G dash equal to vector G minus omega vector cross vector R. The observed value of acceleration due to gravity at P, taking into consideration the effect of centrifugal acceleration and neglecting the effect of coriolis acceleration due to the rotation of the earth is given by G minus G omega cross vector R, where G dash equal to minus G cos lambda I plus sin lambda j minus omega j cross vector R cos lambda I, where is minus G cos lambda minus omega square R cos lambda I plus G sin lambda j magnitude of G dash magnitude of G dash equal to G cos lambda minus omega square R cos lambda square plus G square sin square lambda whole to the power 1 by 2. Then the value is in bracket G square cos square lambda in bracket 1 minus omega square R upon G whole power 2 plus G square sin square lambda whole to the power 1 by 2. And next is G square cos square lambda in bracket 1 minus 2 omega square r upon G plus G square sin square lambda whole to the power 1 by 2. Since omega square r upon G is very less than 1, its square is a negligible quantity. Its square is a negligible quantity. Negligible quantity. Then the value of G dash. Then the value of G dash equal to G cos square lambda minus 2 omega square r cos square lambda upon G plus sin square lambda whole to the power 1 by 2. Then G in bracket 1 minus 2 omega square r upon G cos square lambda whole to the power 1 by 2 equal to G in bracket 1 minus omega square r upon G cos square lambda equal to G minus omega square r cos square lambda. Then taking r equal to 6.38 into 10 to the power 6 meters. 10 to the power 6 meter. 6 meter. The value of r omega square equal to 6.38 into 10 to the power 6 in bracket 2 pi upon 24 multiplies 60 multiplies 60 whole square. Then the value is 0.03372 meter per second square. Meter per second square and 3.372 centimeter per second square at the equator. At the equator. Lambda equal to 0, cos lambda equal to 1. Then the G dash equal to G minus omega square r cos square lambda equal to G minus omega square r equal to G minus 3.372 cm per second square. Due to rotation of Earth, the value of G at the equator decreases. So due to rotation of the Earth, the value of G, the value of G at the equator decreases by 3.372 cm per second square at the pole. And next is at the pole. At the pole, lambda equal to 90 degree and cos lambda equal to 0. Therefore, decreases in the value of G due to rotation is 0. Due to rotation is 0. Due to the observed difference between the value of G at the poles and at the equator is about 5.2 semi per second square. This is due to the fact that Earth is flattened at the poles, and even it is were not rotating, the value of G at the poles would have been greater than that the equator. At latitude, that means 45 degree. At latitude, the decrease in the value of G at latitude 45 degree, the decrease in the value of G, the decrease in the value of G equal to R omega square cos square lambda equal to 3.372 multiply 1 by 2 equal to 1.686 cm per second square. Hence, if the earth were to stop, if the earth were to stop rotating, the value of G at the equator, the value of G at the equator will increases by 3.372 semi per second square, and at a point in latitude by 1.686 semi per second square. In other words, the effect of centrifugal force, the effect of centrifugal force, the effect of centrifugal force due to rotation of the earth, due to rotation of the earth, and the acceleration due to gravity is, acceleration due to gravity is maximum at the equator and minimum at the poles. Maximum at the equator and minimum at the poles. Thank you.